Hello, thank you for joining us for our today's webinar, the Silverchair Universe presents Meta. My name is Stephanie Lovegrove. I'm the marketing manager at Silverchair, and we're excited to have with us today Greg Tannenbaum from Meta, who will be taking us through Meta's offerings as part of the Silverchair Universe. Really quickly, just a couple housekeeping things. If you have questions throughout the course of the webinar, feel free to put them in the chat box below. And we will also be sending out a survey afterwards. We appreciate if you could take a moment to fill that out. It helps us to continue to improve our offerings as well as our webinars themselves. You'll also have a chance in there to ask any questions you didn't get a chance to ask during the webinar. The webinar is being recorded and a link will be sent to you afterwards. We'll also have a copy on the website. All right, well now I am going to go ahead and hand it over to Greg.
Thank you. It's my pleasure to be here. I appreciate the opportunity, and I am going to hopefully set up my screen so that folks can see. Stephanie, is my screen now presenting?
It is indeed.
Perfect. So I'm going to now try and maximize that so it's in full presentation mode, and away we will go. Terrific. So again, I'm Greg Tannenbaum. I run strategic partnerships for Meta, and I'm pleased to be with you today. I'd like to start by defining the problem/opportunity that Meta is addressing. So I think we all know that there are many more articles being published every day than a researcher can reasonably keep track of. And this means that researchers who could be tackling big societal challenges or making substantial progress on curing insidious diseases are not optimally positioned to build upon important new developments. There are actually on the order of 6,000 new papers in biomedicine get published every day. And given that volume of papers and their complexity, meaningful engagement really increasingly requires new classes of products and services, AI-enabled systems that are able to read and to understand scientific literature at scale. Why this matters? Well, a huge percentage of researchers believe that they're missing important papers in a typical month. It's actually 85%, according to recent NPG survey work. So 85% of researchers are aware that this is a real problem. So the goal of creating tools that allow for more meaningful engagement with the literature and a deeper understanding of what is happening in the scientific literature, the need for that is very real. But it's certainly not an easy task to figure out how to do that, in part because we're dealing with the densest and the most information-rich documents on Earth when we talk about scientific articles. When we talk about people throw around the term big data quite frequently, but when we apply it to scientific literature, it really means big in two different ways. Big, the volume, right? There are 6,000 new papers every day, but big also means complexity. There's a lot of rich information contained within each of those articles. And just again, to put a cap on this, the percentage of researchers that wish that they could be more up to date with the latest research in their specialty, their discipline, it's 73%. So it's a very, very high number. 3 in 4 researchers feel this problem acutely. So what is Meta? Meta is a tool that is used to discover biomedical research in real time. And our aspiration is to ensure that researchers never miss an important paper, that they're able to see advances in emerging trends, particularly at the intersections of fields and disciplines. And they're able to save papers and learn about them and dig deeper if they're so inclined. So this is really what Meta is all about. We are a team of data engineers and bench scientists who are focused on a mission that is simultaneously very simple and very ambitious. Our goal is to unlock all of the world's scientific and technical insights using artificial intelligence. And how we do that is we machine read, we process, and then we create structured connections across all of this scientific literature. And we do this free of charge for all stakeholders. Meta is part of the Chan Zuckerberg Initiative, which is the not-for-profit philanthropy founded by Facebook CEO Mark Zuckerberg and his wife, Dr. Priscilla Chan. And as it says here on the screen, CZI has a goal of curing, preventing, or managing all diseases by the end of the century. Meta fits into that larger goal by providing scientists with the means to make sense of the vast amount of research that's being produced around the world. We believe that we can create a more efficient scientific process in furtherance of that goal. So Meta is built on content that we've obtained through our partnerships with organizations like Silverchair and with direct relationships with publishers. So we have indexing agreements with thousands of the world's leading publishers, and more are being added all the time. We actually have indexing rights to about 50 million full text papers, so it's quite a large corpus. And what we do is we use the information within the papers to generate what we believe is the world's largest and most complex scientific knowledge graph. We identify and we map and we rank the connections between and among millions and millions of different entities, essentially mapping the entirety of science, both today and how we got there. And that scientific knowledge graph contains lots and lots of very rich information. So billions of recommendations, hundreds of millions of citations. Specifically, we have entities like genetic elements and researchers and antibodies and drugs and bacteria. And all told, we have about 5 billion knowledge graph connections that really help define and bring dimensionality to this knowledge graph. And so what I'd like to do now is actually dig into the service itself and show folks how it works and what it looks like. So I'm going to transition here momentarily, and hopefully you can all see we're on the Meta service now. Again, this is completely free to use, and researchers sign up and they can choose from a variety of pre-baked feeds, and I'll talk about feeds in just a second, that our team has created through a combination of artificial intelligence and human biocuration. They also can create their own feeds as well, and I'll show how to do that in just a minute. So I mentioned this idea of feeds. What is a feed? A feed is an AI-powered stream that Meta members use to follow important new research. And feeds can be used to track concepts, people, genes, diseases, and a variety of other scientific elements. And Meta updates these feeds in real time as new papers are being published. So I want to dig in and show you with some specificity how Meta operates. I am following a variety of different topics here, and you can see these are the feeds that I have created. There are simple feeds that one can follow, and there are very complex feeds. So this one that I'm looking at here, indomethacin, is relatively straightforward. So if I click on this indomethacin feed, I can show you, let me just show you a little bit about what's in it. I am following one thing, which is indomethacin is a medication, and I am just following this one concept. Meta suggests, as we start creating these feeds, Meta suggests related concepts, researchers who work in this area, journals that tend to publish on this topic. So I can enhance this feed, and I can create, if I'd like, I can create very, very complex feeds. So at the other end of the spectrum, if I look at something like I have a feed for cardiovascular diseases, and I look at what that feed contains, you can see I have lots and lots of different concepts and the intersection of different concepts as well. So again, feeds can be very, very straightforward, following just one thing, or they can be very, very complex, following lots of different things. So what does a feed actually produce? Well, a feed produces a list of papers that are relevant to the topics contained within that feed, within that stream. So Meta will produce this list. So there are 29 within the cardiovascular disease risk factors. There are 29 papers that have been published today that fit the feed that I've created. And Meta will show you within that feed why the match exists. So this paper is surfaced to me because cardiovascular risk factors is one of the terms I'm following. This one is surfaced for me because it's at the intersection of heart diseases and obesity. This one is surfaced for me because I'm specifically following the American Journal of Cardiology. So there's context given to me when I'm looking at my feed. And again, a feed is just a stream of papers that shows me new content of relevance to my research interest. You can see here there are 29 new papers since the last time I was on this feed. They're flagged by this little new tag here as well, and that gives me some insight into what I have not seen since the last time I have been within Meta. So if I scroll through, you'll see there are lists of papers here that are hopefully relevant and interesting to my research interests. I can click on any one of them, and I will receive more details. So if I go back to indomethacine, which is a topic that I mentioned I was following, I also can see, by the way, some alt metrics as well. So this paper, for example, has 5 Twitter mentions. I'm not sure if any of these other ones. So this one has 2 Facebook mentions, has been saved 23 times within Mendeley. So I get some sense of that as well. So if I click on a paper, I will see a pane come up on the right that gives me additional details within the meta view. And we've done extensive user testing in a way that is really interesting and exciting as far as I'm concerned. So specifically, what we're able to do here, this is a subtle thing, but I think is quite useful and relevant. We are able to show additional information, additional details about this paper, but also keep this feed view intact as well. I can kind of look and have a dual purpose view. If I decide I want to find out more about this paper, I can click on the Show Details button, and you'll see it's going to take over the rest of the screen, and I'll get an additional view into this paper. So I get the abstract, I get related papers, I get references, I get citations, and so forth. And if I want to actually get the paper, there's a button that says Get Paper, and I can access this in a variety of different ways. So one is I can be taken to the PubMed record, I can be taken to the publisher record. We also work with third-party plugins like Unpaywall and Copernio that are excellent at finding the best legal copy to which a researcher has access. So for example, if I am at Stanford, Copernio or Unpaywall can identify that I'm at Stanford. Stanford subscribes to JAMA, therefore I'm authenticated and I can get the JAMA published version of the paper. If a version exists on PubMed Central, or if an author has posted a copy, a legal green open access copy into his or her institutional repository, these services can identify that as well. They don't work with Sci-Hub or other illicit copies. It's a way to be simultaneously balancing the copyright considerations of the journal and also the interests of the researcher in getting access to the full text of the paper. I want to show just a few more things, and then I think I will pause. I want to show how to create a feed, just get into a little bit more detail about how that works from a practical perspective. So there's a link over here, or sorry, a window over here that says Explore Research. And if within that, if I start typing in, let's say I'm interested in kidney carcinoma. So if I start typing in kidney carcinoma, it is going to give me some suggestions, so some terms that are most relevant to that search. So I can select renal cell carcinoma, for example. And when I do that, you'll see there's going to be some information that populates the screen. So for example, it is going to show me that the term renal cell carcinoma on average generates about 7 papers a day. and that about 70,000 researchers have published in this across 2,100 journals. It'll also show me the related researchers, so the authors who are most prolific and most impactful when it comes to this topic. It'll show me related diseases, so I can, if I want to focus on neoplasms, for example, within the renal cell carcinoma search. It'll show me the proteins, which are most commonly associated with this term. The clinical terms as well, substances and cells and functions and anatomy and organisms and so forth. So I can use these suggestions, or I can create my own to suggest or to create a feed which is of direct relevance to my interests. As I start building this feed, you'll see it shows me the 145,000 papers that have been published since 1905 on this term. We sort them by impact. So this is not projected impact, but actual impact. This is a paper from 2012. It has lots and lots of citations. It has lots and lots of altmetric impact as well. If I wanted to look at just the most recent papers on this topic, I can change my view and I can see papers. So this one was published 2 days ago, for example. I also can look, if I want to, for example, look at just review articles. So I want to find, I want to orient myself on this topic. A review article is a way to do that. I can limit my my search or my stream to that. Or alternatively, if instead of reviews, I want to look at preprints, I can do that as well. And I can click on, I actually just unclick, but let me try that again. I can click on preprints. And right now we're indexing bioRxiv preprints. We'll expand the portfolio of preprint servers in the very near future. And this is obviously a good way of keeping abreast of a given recent developments in a given field. So I can save this as a feed if I'm so inclined. I also can create variations of a feed. So for example, within Parkinson's, inosine is a very important term. And within inosine, I can create feeds that are topic-based, so follow a variety of topics within inosine. I can create a feed that focuses specifically on journals and what they publish. So this one, for example, looks at specific top journals that I want to focus on, so like Nature and Cell and Science and so forth. I can create a feed that just looks at preprints within inosine. Or I can create a feed that follows specific authors that are prolific on this term. I can create this into one single feed, or I can also, of course, create these distinct feeds as I've done. Now, when I find a paper that's interesting to me, I haven't been on the site for a while. This paper was published last week. I think I want to explore it further. Meta allows for a very efficient triaging, so I can just click on this bookmark, and when I do that, it's saved to my library. So if I click on library, this is not saving the full text, it's just saving the record, and I can go back later and I can read the abstract, and I can go and get access to the full text if I'm so inclined. The last thing I want to talk about, and I don't have a screenshot for it, but I'll just mention it, is we realize that there are different ways to access content, and there are different ways to stay abreast of developments within one's area of research. So specifically, some people, some of our users come to Meta on a daily basis, much like they'd go to Twitter or Facebook or other sites that they have just made part of their daily online routine. And they come and they see what new papers have been published in their research areas. So for example, I'm following venous insufficiency. I come back to the site, I see this green dot, that means there are new papers. I click on this, and it will show me there was one new paper that was published today on this topic. We also know that folks are busy and they have different ways of interacting with different tools. And so on a weekly basis, we send out digests that in effect summarize new papers in each of the feeds that a person is following. So I get an email once a week for each of these different feeds where there are new papers. It shows me something very similar to what I'm seeing here. And if I click on a given paper, it takes me directly to the meta record for that paper. And so we realize that there is both a push and a pull that can, both of which can be effective in bringing folks, bringing new papers to the attention of folks who are doing research in a given area. And we want to make both of those viable within the meta experience. So we have lots of plans, obviously, to improve the experience, to add more content types, to make the jumping off point when someone finds a useful paper, to make that jumping off point to follow on research more efficient, to improving the user experience. But I think this gives a fairly good overview of where we're at. As I said, this is completely free for publishers. It's completely free for end users, for researchers. There's no advertising. There's no selling or packaging of user data. This is really a completely free service, and it is meant to be, as I said, in service to this larger mission of CZI trying to cure, prevent, or manage all diseases by the end of the century. So I think I will leave it at there. I know folks often have questions after the fact. I see there's not anything that's popped up in the chat window, but I'll leave my email address here. And for folks who are on the line now or who are watching this on a video delay, if you will, you can certainly contact me with any questions that you may have. And I think with that, Stephanie, I'll turn it back over to you.
Great, thank you so much. That was extremely helpful. It's great to see it in action too, both from the, from the researcher's point of view, and then, for the publisher. I know that you're already working with several people on the Silverchair platform, several publishers, and we've got that process pretty streamlined now. We send the content directly to Meta. As Greg said, it's a free service, and with Meta being part of the Silverchair Universe, any additional work that happens on Silverchair's end is likewise a free service. So it's a really great thing to get your content into. All right, well, I don't see any other questions. So unless you have anything else, I think we can probably wrap there. I will say, like Greg said, reach out to him directly if you have any questions. If you are interested in getting started, you can also get in touch with your PDM or your customer success manager, and they'll be able to get things rolling.
Thank you. It's my pleasure.
Thank you very much for joining us.